You know how a honeycomb fits together so perfectly? Or why a stop sign has that exact unmistakable shape? Well, it turns out it's not random at all. The entire world of shapes, from what we see in nature to our own designs, is actually governed by a secret set of really simple, elegant rules. And today, we're going to crack that code.
So check out a pattern like this. You see all these different polygons, squares, triangles, hexagons, all locking together without any gaps. It's beautiful, for sure, but it's also deeply mathematical. So what's the secret? What are these hidden rules that let these shapes fit together so seamlessly?
To figure that out, we've got to start at the very beginning. Let's forget the complex stuff for a minute and just think about the simplest, most basic polygon there is. What do you think it is? Yep, you got it. It's the triangle. This simple, three-sided shape is the absolute key to everything else. Seriously, once we understand the rules of the triangle, we can unlock the secrets of pretty much every other polygon, no matter how complicated it looks. Okay, here's a really simple experiment you can do, even just in your head. Imagine you draw any old triangle on a piece of paper, and then you just tear off the three corners. Each corner, of course, has one of the triangle's inside angles. So what happens if you line up those three torn-off points right next to each other? And boom, look at that. The outside edges of those three angles form a perfect straight line. And this works for any triangle you can possibly imagine. This is not a coincidence. A straight line itself represents a very specific and a very, very important angle. And that magic number is exactly 180 degrees. So here's the big takeaway. The sum of the interior angles of any triangle, it doesn't matter if it's long and skinny or perfectly balanced, is always 180 degrees. Remember that number. It's our master key. All right, now that we have our 180-degree master key, let's see what doors it can unlock. We can use this one simple rule to figure out the angles inside way more complex shapes. Because it turns out every polygon is basically just a collection of triangles in disguise. This brings us to the next logical question, right? I mean, a square, a pentagon, a hexagon, they clearly have way more than 180 degrees inside them. So how do we figure out the exact sum for each of them? The trick is so simple, it's brilliant. Just pick any single corner, or vertex, of a polygon. From that one spot, draw straight lines to every other corner you can connect to. Just doing that instantly slices the polygon up into a neat little set of triangles. And this method shows us a really clear pattern. A quadrilateral, a shape with four sides, gives us two triangles. So that's 2 times 180 for a total of 360 degrees. A pentagon, 5 sides, breaks into 3 triangles, which is 540 degrees. Are you seeing the rule here? The number of triangles is always the number of sides, which we'll call n, minus 2. And that gives us our awesome formula for the sum of interior angles in any polygon. Just take n minus 2 and multiply it by 180. Okay, so we have totally cracked the code for what's happening inside the shapes. But that's only half the story. To get the full picture, we need to meet a new character in our story, the exterior angle. First, just a super quick recap. The interior angle is the one we've been dealing with this whole time. It's the space on the inside of a corner where two sides meet up. Simple enough. Now, say hello to its neighbor. If you take one side of a polygon and just keep drawing it straight past the corner, the angle it makes with the next side is the exterior angle. A good way to think about it is it's the angle you have to turn every time you reach a corner if you're walking along the edge of the shape. So let's put them side by side. Interior is inside, exterior is outside, but they share a corner. They share a side. They are inseparable partners at every single vertex of the polygon. And their relationship is actually really special. Together, they form what's called a linear pair. You can see right here how they sit perfectly along a straight line. And we already know something about straight lines, don't we? Yes, they add up to 180 degrees. So at any corner, if you know the interior angle, you instantly know the exterior angle. And the other way around. They're a team. Okay, this is where it gets really interesting. This relationship leads us to our final, and maybe the most surprising, rule of all. We've seen that as polygons get more sides, their total interior angle sum just gets bigger and bigger. But what happens when we look at them from the outside?
So just think about that for a second. A triangle has 3 exterior angles. A hexagon has 6. An octagon has 8. So if we add all of them up for each shape, does that sum also just grow forever? Or is something else going on entirely?
Here is the mind-blowing answer.
It doesn't matter if a polygon has 3 sides or 3,000 sides. The sum of all its exterior angles is always 360 degrees. It's a universal constant for any convex polygon, which just means a polygon where all the corners are pointing outwards. Always 360.
And if you're wondering why that works, check this out. Imagine we could just snip out the exterior angle from each corner of this pentagon. Now, if we slide them all together so that their points meet right in the middle, look at that. They form a perfect circle. And a circle, as we know, is 360 degrees. This works for any polygon, and it basically represents the total amount you have to turn to walk the entire perimeter and end up facing the exact same direction you started. So, we've just uncovered 2 fundamental rules that govern the entire world of shapes. But this isn't just some abstract math problem. This is the hidden code that builds the world all around us. So let's recap that code. The inside rule, the sum of the interior angles is the number of sides minus 2 times 180. The outside rule, the sum of the exterior angles is always 360. That's it. Simple, powerful, and universal. And why does any of this matter? Well, this code is why bees build hexagonal honeycombs. Their interior angles fit together perfectly to tile a surface with incredible strength. It's why the angles of a stop sign give it that clear, universally recognizable shape. And it's why all the triangles in a bridge truss create an unbelievably stable structure that can support massive amounts of weight. These aren't just rules in a textbook. They are literally tools for creation. From art and design to engineering and architecture, understanding this hidden language of shapes gives you the power to build, to create, and to see the world in a completely new way. So now you know the code. What are you going to build with it?